Thank you to everyone for joining today. Really excited to talk about this. If there are a lot of opinions about Snowflake architecture, then I'm really excited for a robust conversation and definitely prepared to have my mind blown and maybe completely change my perspective on what we've been doing. But who knows? We'll see. So, without further ado, this is what we've been doing at Ritual in the past quarter, basically. And we've codenamed our project Yeti because we wanted to build an analytics piece. And essentially, going into this project in this last quarter and deciding how we wanted to architect our Snowflake platform, we were coming away from BigQuery, and we had a couple challenges in BigQuery, and we really wanted to solve them when we sort of redesigned an analytics platform on Snowflake instead. And so the main two problems that I'll sort of like go back to throughout this presentation are we wanted a architecture that would allow us to rapidly and confidently test and deploy our models. On BigQuery, we sort of had this manual deployment process where we would put things in different projects, different Google Cloud projects, and sort of stage them and maybe like manually deploy them to like one environment for one day and then wait, see if anything broke, manually deploy to another environment. And it was just like a lot of, we felt wasted time for how quickly we wanted to be able to, build new DBT models, get out some analytics and hook it up to Looker for the business team. And the second thing that we really wanted to solve here was essentially clear permissions and understanding who has access to what, because previously on BigQuery, we started designing sort of that warehouse when we were a much smaller company. Permissions were very broad, and so most people in the company kind of could just go anywhere in that warehouse, and it was just like unclear what everything was. People like would make schemas manually. This was like before DBT, before we adopted DBT. So yeah, we really wanted to like do a good job of trying to think about like some access controls on Snowflake in the beginning and a way to like manage them effectively and manage and version control changes to them. Just a little bit more background before I get ahead of myself. So at Ritual, we're basically a local commerce order ahead app. We're based in Toronto. We're primarily focused on the food vertical. A lot of our data is therefore related to like events on our app. But this specific architecture works for us with that amount of data. But I don't think that it's necessarily, I think it is actually applicable to a larger sort of audience. So hopefully you'll find something useful in here as well, and it'll be valuable to you in that way. So when we thought about redesigning our warehouse and going to Snowflake, we really liked the features that we thought could actually help meet those two sort of goals that I laid out earlier. One being, how do we confidently test and deploy things quickly? And the other, how do we have a robust sort of access control system? So the grants in Snowflake led themselves to the access control, and the zero copy cloning was a great feature that we were excited about. And so we got inspired by, there's a talk from a data engineer at GitLab that sort of initially planted the seed for us for this idea of like infinite databases and how could you sort of copy your production environment so that you can really easily test changes and also develop in a way that you're confident that what you're working on will actually work as expected in prod. And of course, we were incredibly inspired to the point of plagiarism by the How We Configure Snowflake DBT blog article. We found that like a really good starting point. I'm about to go into our architecture, which really mirrors that How We Configure DBT blog post. But before I do, quick note. So in that blog post, the two database approach is raw and analytics. We are following all like the same approach, except we've aliased analytics as gold. So as we go through and you see code and you see like diagrams, just think gold equals analytics database in the Snowflake warehouse. So this is essentially this architecture diagram that we've come up with here. So as you can see, this is exactly like kind of the framework laid out in the How We Configure Snowflake by the DBT folks, which is a fantastic approach. So basically underpinning most of this, so think of like these roles that are in this hierarchy: reporter, transformer, loader, and the corresponding warehouses and the two database system. So the only really like novel thing here, it's not really well portrayed on this diagram, but the novel thing is basically we manage all those permissions through Terraform, which we'll get to in detail later. The thing that we don't really manage through Terraform, and this is sort of the trade-off point between Terraform and DBT in our architecture, is the gold warehouse. So in Terraform, we create and specify this gold warehouse, but then we don't want to manage the objects directly through Terraform that are in that gold warehouse. So you can kind of think about like everything in this picture, with the exception of the gold warehouse, or sorry, gold database, is sort of managed by Terraform, but then the objects in the gold database are essentially, it's a DBT project, and they're all managed by everything in that DBT project. So we don't sort of, that's essentially how we trade off those permissions. So one really like useful benefit that we found in adopting this architecture and the two database sort of system that DBT recommended was with Snowflake, there's the zero copy cloning approach. And essentially this solves that first point that I was talking about earlier of we wanted to confidently and rapidly develop and deploy models. So the really nice thing with the zero copy cloning is that it doesn't take up more storage. It's for anyone who's not familiar, it's just a copy command. You kind of copy an object, but it doesn't increase the storage that you're using in your Snowflake account. It sort of aliases the data to create like a clever symlink, and that's how you can have sort of two different references to the underlying same object, but they're actually kind of treated as different objects in the database. So so basically, because the gold/analytics database is managed by DBT, and the raw database is just like a landing zone for events and transactional data from our application, other data sets that we're interested in, the amount of data that we're actually storing in the DBT project in Gold at any time is low, because a lot of the things that are built in Gold and DBT are views, right? And then we have some incremental materializations and a couple tables. But overall, it's like a smaller subset than what's in raw. And so this actually we found in our CI and our development approach that because there's so much less data in the Gold database, it's a really good candidate for the zero copy cloning sort of development approach. So basically, with just like a few simple components, essentially like a pre-hook sort of cloning macro that we run, override of the generate database built-in macro, and a cleanup, we sort of like put in the pieces for both our CI and our developers to be able to spin up a copy of our essentially production database at will, make whatever changes they want, and then we can really confidently test those, because the CI actually makes a copy of production, tests the changes, passes them, and then one approval, and it's deployed immediately into production. So this is an example of like what these macros actually are. So it's just really straightforward. So this is a macro that like an analyst would run prior to starting like the development of a new model. So they would just do dbt run operation, clone database. Essentially, it spins up a clone of Gold. Actually, in our warehouse, these are all prefixed with, as you can see here, this clone. So in our I keep saying warehouse because I think BigQuery and I think like data warehouse, but in our Snowflake account, you can see like these databases getting created, and it would be like Teghan, like clone, Teghan, and then like the Gold database. Or it'd be like clone, this PR number, the Gold database. And then it's so clear, like, first of all, like that user is typically the only one able to see that in the account anyway, because they are the ones that like ran the clone. They don't get to see other clones. So it's like personal to them. And secondly, so it's just like a really simple way we found for people to iterate and develop quickly, and as well as like it's used by both our CI and and these developers. Nice. Okay. I was just checking the chat in case I missed something. Yeah, and then finally we just have like a cleanup macro basically that when the CI is done, this copy, and then it applies like a dbt run and a dbt test on those changes. Essentially this macro just tears down that clone that was created of the gold database. And then this is also used to like run like a routine cleanup job, like at the end of the day to wipe all the developers like random clones that they made throughout the day if they were working on stuff.
Are you running that as a run operation?
Yeah, so essentially, exactly. We have the documentation for our analysts. They know before they start like anything on a new branch, they just do run operation, clone, and then that basically sets them up. Because we're overriding the generate database name built in, all their subsequent sort of dbt commands that where they use the dev profile automatically like resolve to like the correct database for their clone. So when they just run dbt run, because by default they're using dev, their run will happen on their clone and their testing will happen on their clone, which is just an amazing feature of dbt. This like overriding these built-ins is great. So yeah, it's a run operation. The analyst runs it manually before working, and then also the CI just runs it before testing. And then we just tear down after with another like run operation. So yeah, so this has been like a big change for us. This is really cool because now like we're really happy with how decoupled this is from like before. We had like these three environments, we had these manual deployments. It was kind of like a hassle. And now we're just really happy that basically anybody can, open a PR, know their changes are being basically tested on prod data. For context, like, of course it can be expensive if you're testing like everything or running everything for each PR. So we actually we run the subset of the dbt DAG for just the change models, their parents and their children. So that kind of cuts down on costs. And then we also have like for incremental models in the CI, we kind of have like a buffer to make sure that they're not actually like fully running or fully refreshing in the CI. So yeah, this has really like enabled us to basically deploy our stuff almost immediately, because on a merge to master of that PR, we do a dbt prod run. Our CI is GitHub Actions. So GitHub Actions does a prod run, and this basically immediately deploys their changes into the gold. And now when anyone subsequently, is like developing right after them, as soon as they run that clone database, they're getting all those most recent changes as well in their new like development environment. Yeah, so that's kind of like the success we've had addressing the first point of our goal here, which was basically how can we rapidly test and deploy models and be really confident. The second part is how can we manage access control confidently, transparently, and hopefully in a way that is like version controlled, so that we can really understand like who's seeing what in the data in the Snowflake account and who's able to run what kind of things. So we considered a couple options when we were looking at this. I know GitLab has a great little tool called permafrost, and at first we were really taken with permafrost. We thought it was like really exceptional, but we quickly realized that it does a really great job of managing your grants. But if you kind of want to have a complete sort of architecture of grants as well as objects and manage the entire ecosystem of your warehouse, Terraform is more the solution that enables you to do that. So we use this external provider. It's open source. It's early stages, but it's worked well enough for us so far. It's sponsored by it's part of the Chan Zuckerberg initiative. So they've open sourced this and they maintain it. It's fairly straightforward. And it basically has, if you're familiar with Terraform, the backbone of Terraform is this concept of a resource, which just is like an abstract reference to a particular piece of infrastructure or object in whatever system you're administrating. So in Snowflake, there's resources to represent databases, schemas, pretty much every Snowflake object through this open source. Provider is just the Terraform word for essentially library. So the key points here, actually the limitations of Terraform. So I mentioned this earlier. So Terraform does not manage like all the objects in gold. We sort of like have this switch point between Terraform, which manages the creation of all the objects, the grants on all the objects, except for those objects and grants that are within the DBT project itself, within the gold database, which is the DBT project. Because we just found that it's better to kind of like draw that clean line, just like cut off and let DBT sort of manage the creation of those via the transformer role. And yeah, so without further ado, so this is an example. This is a diagram. This is like a Terraform graph, basically. And so this is kind of how we've set up our hierarchy. So this represents like the order of operations when we essentially do like a complete Terraform run. We found that just for like simplicity, we essentially try to create one resource type per object, and that resource type is essentially a map that has keys to the individual like components. So this allows us, one, to kind of like visualize a lot easier what's going on in our warehouse from a high level. So like in this graph, for example, because everything is sort of rolled up into what it is in terms of an object. So instead of like the warehouses for transformer and loader and reporter, those are all just sort of maps within this resource here. So within the Snowflake warehouse resource, essentially there's keys for like each of those sort of sub objects in that resource, like the reporting warehouse, the transforming warehouse. And this kind of ensures that, this is the other really important part, this ensures that when we create our architecture, everything, like it's easy to organize the hierarchy of what objects need to be created before other objects. And this is really important to allow us to, if we want to completely like restart or tear down our warehouse and rebuild the infrastructure from scratch, because everything is created with the correct like dependency hierarchy. So it's counterintuitive with the arrows. I'm pretty sure they actually run kind of like reverse to what you're seeing here, or this is kind of like a teardown. But basically, we start with building like our databases, our warehouses, and then you can just follow the arrows backwards from there. So essentially, after we've created all these like integration stages, schemas, databases, and warehouses, we build the roles, and then finally we apply the grants to everything after all the objects are created. And so this isn't typically even something that you have to manage like explicitly in the Terraform files. Terraform automatically kind of infers this hierarchy for you, which is really useful. There are a couple cases where we did have to kind of manually tell Terraform, like, you need to do this before this, otherwise it keeps failing. So in general, it's kind of useful. So let's go. We're gonna switch to like a kind of tangible example, and actually show you guys some code so that we can have a bit of a discussion, kind of show why this has been beneficial for us. So this is an example. So this is an example of a PR using this approach. So we have this repo, the Yeti repo. I opened a PR creating a new storage integration in Snowflake, essentially. So I want to create a new storage integration. And so we're tracking this through code. So you can see here that, so even before I do this, it might be useful to. So in our repository here, Yeti, we have our DBT project. We also have this Terraform folder with these infrastructure files. And so we've kind of like created a .tf file for every type of object that we're interested in managing. So just with that context, going back to this PR here, so you can see like, if I want to create something new in the warehouse, yes, like in the past, like obviously you could just go in and, you know, create my storage integration, run a couple SQL lines. This lets us sort of basically version control and track what's going on in the state of our of our warehouse so that anyone can kind of reference and understand immediately like what is created, who owns what, what's going on. So you can see with a couple like declarative lines here, I basically create the objects that I need in the warehouse, and then they are actually applied when this is actually merged in. So then they're just created in the warehouse on the merge, which is, we just really like that approach to kind of make sure that everyone understands what has been created and anyone can propose changes to the architecture without needing to be an account admin, right? Anyone can sort of say, hey, I have this PR, I want to, create these things or grant these permissions. Can you approve this? Is this fine? So there's a question in the chat. Can you explain why you went with the map approach instead of just having one resource, one object, one DB, one schema, one role? Yeah, I think what this is saying is why did we make our resources, like why did we create one resource per object type instead of, two database resources, one for each database? The answer is, sorry, let's switch tabs. The answer is it's just kind of, it's easier to control and understand the hierarchy in which things are being created. And it's also a little bit more like dry in terms of the configuration and the declaration. So if we look at, this is an example. So if we look at this is our schemas Terraform file. And so if you look at this is what you saw on the map earlier, schemas. So we create this one resource per this object type. So in Terraform, one more question in the chat I'll get to in a sec. But yeah, we essentially, by creating one resource per object type, it's just a little bit more dry because we can kind of declare like a couple things once. And then we kind of just, this is like the map that I was referring to. So within this object, this like parent schema object, we've created these basically keys in this map where they refer to the specific things that we want to sort of create. It's just a lot cleaner. It helps us visualize it better. It helps us manage the hierarchies better. And again, to address the most recent question, when the code is merged, who runs it? So our CI is a user that has account admin privileges. And so the CI can apply the changes at the highest level of permissions. And that's how all these things are created. So yeah, so like with this framework, creating a new like storage integration and a stage and a new schema is as easy as just like inserting, a couple declarative lines here. And then what our CI looks like is, this is actually something that we want to improve on. So Terraform has this concept of like Terraform Cloud and workspaces. And essentially this Terraform Cloud service, you can authorize it with GitHub and it will sort of run certain actions for you automatically on PRs. And it will like manage the provision of basically ensuring that, you can sort of test your changes in like a sub Terraform workspace, like a QA workspace on the pull request. And then when that works, you can, when it's merged, it automatically sort of applies as well. So that's like some very nifty features with the Terraform Cloud product. We didn't have the backend support that we needed in the time that we wanted to set that up the way we wanted. So we kind of manually created that process through GitHub Actions, through the command line interface. But essentially, like we're achieving the same thing. So if I go to this Terraform job here, so this is an action that ran this is on our CI on this pull request. And so basically, we just have to install Terraform, initialize it, ensure it's working properly, and then we have these stages here. So plan and propose changes. So basically Terraform ensures that what we're planning to do is valid and it's consistent with the rest of the permissions in the Snowflake accounts. And so basically this is a Terraform plan for anyone who's familiar. And it's basically saying we're going to create the following 3 resources. These are going to be the attributes. And so anyone in the PR can go and look at this and say, oh, yeah, that makes sense, or oh, no, that's not right. And if it's invalid in any way, it just won't succeed at all. So that it'll just kind of fail. So that's kind of nice. The other thing that we do, this is how we kind of manage, this is our alternative to, this is like manual workspaces through the command line interface with Terraform. So we basically, on a pull request, we had problems where this provider is fairly young. And so maybe a Terraform plan, like what we saw below, of we're going to add these three resources, maybe that's like a dry run, right? So that's saying we propose these changes. Even if that, those proposed changes seem fine in the dry run stage, when they're actually applied, things can go wrong really quickly, and it actually might not successfully complete the operation. So our solution to that is we pretty much do a complete, we create a new workspace, which is like a new environment, and we allow basically a complete run of Terraform in that environment. So we say, like, starting from scratch, run our entire infrastructure in this like QA environment and ensure that everything is created and works consistently with itself as expected. And so when this succeeds, we're like, okay, then it's fine. Whatever changes have been, proposed are consistent with everything else. So it's basically like an integration test. And that's really it. And so then when this was merged, this Terraform apply step is then utilized as well. And so that's when the account admin role basically authenticates Snowflake and applies these changes so that these objects are created. And so moving back now, so now I think if anybody has any questions, we can actually just dive into the Terraform files directly. And if anyone has questions about how we structured these, or how to sort of start managing their own architecture through Terraform, I'd be happy to answer. And I can share all the code that's in here with you guys.
Sure, Teghan, I've got a question for you. I've seen in the Chan Zuckerberg repo that there's obviously limitations to how many resources they provide. So for instance, they don't have like a network policy resource. And they've said that they only they really prioritize features that they themselves need. Have you run into any major limitations with this provider? And if so, have you been in touch with them, and have they been receptive to adding new resources for you?
My perception of them is that it's just like a self-serve open source thing. And I don't think that, I'm totally with you that I don't think that they would necessarily take the initiative to build resources that the community is requesting, but it's something that I hope to get more involved with and sort of contribute directly to. So I think that we have encountered very few limitations with the resources that they have currently. The network policy that you mentioned, I wasn't aware of, we don't use, it isn't crucial for us. So overall, it's been very good for our needs. The only thing that is sort of troublesome, this is actually highlighted here, is for grants, they don't currently have a way to do an all clause on grants in a specific object. So if you wanted all tables in this particular thing to be available, if they want you to apply it table by table, they want you to create a resource for select is available on this table, and then all the 100 tables in your schema. So I think that that's a fairly low hanging fruit. I anticipate they will sort of solve that in the future, or somebody will, contribute to the project and solve that, because it's a pretty glaring deficiency. The way that we've addressed it right now, you can see this, we basically make a note and we say, instead of us declaring 100 tables and granting permission on those 100 tables in this one schema to, whatever the loader role, just know that we've ran this one command, and that's existing right now on the warehouse. So that's the main limitation. But I mean, then again, if you put your head down and you wanted to if it is important to you have really granular table permissions for something, and you wanted to put your head down, then at least that granularity is there if you want it. And so you could just, write a bash script, sort of generate the resource sort of syntax for all these tables and granting them to specific things. So that's totally possible. It's just our permissions don't have to be like to the table level and granularity. We're fine just saying the schema is open to whoever. So because of that, we just ran these manual commands and said all the tables in the schema to this person.
Hey, Teghan. My name is Jake Thomas. I have a couple questions regarding this. Oh, sorry. Full intro. Him, and I'm a data engineer at a company in Boston. So my first question, well, I guess I've already asked one of them, and modules was hinted at a little bit. Where were some of the cases that you had to explicitly declare kind of that ensuring hierarchy within the Terraform provider? So like obviously a database has to come before a schema in creation and yada yada. So I'm just wondering, like, what are the glaring kind of pain points there? Obviously this all is certainly one. All is the best. So yeah, just wondering, like, more pain. Here it is. Okay, yeah, this
just search for error.
Yeah, nice. Yeah, that makes sense.
Yeah, so this is an example. This was like a pretty pernicious bug that troubled me for like a good part of a day. Basically, yeah, I'm really glad I documented this for myself.
Okay, yeah, that makes perfect sense. Okay.
Yeah, so basically it's kind of like sometimes the threads that Terraform is running would like destroy a role before an earlier thread that started would destroy an object. And then when it's trying to destroy the object, for some reason it gets freaked out because it thinks the role, when the role was destroyed, the object ownership transferred, I think, to account admin by default. And then all of a sudden it's like, oh, I can't destroy this. Account admin owns this. I can't do anything. So that's like an explicit case. And that's also, this is again, that answer where, you know, we've declared like one resource per object type, and then we just make the map within it to these, you know, specific things. But that works well. Like, it's not,
totally, that's the Terraform way to do it.
Yeah, we haven't really encountered downsides. You can do nice stuff like this, where you're basically, this is like accessing that map. So in the database resource, access the raw database and pull me the name out. And that's what I want this, you know, schema to be built in. Okay. So you can kind of like reference those attributes within the objects that the map refers to in the resources.
Okay, yeah, that makes sense. My other question was with regard to more of like context switching, like who is contributing to this Terraform, and like have you found it to be like a little kind of like yet another thing for an analyst or for an analytics engineer or somebody to learn? Because Terraform looks very different than SQL or Jinja and SQL, which looks very different than Python or like Java and Airflow or whatever, you know. So just wondering if like Terraform took kind of a very intentional and like it took work to kind of go that direction too, because this is usually like the line between like a DevOps team and your analytics org. So
I think that we usually like delineate sort of who would be touching this along the same lines of like that I mentioned earlier of like dbt and Terraform control. So like pure analysts they're just using dbt in the gold database. And that's where we like exchange that control. We say like Terraform declares all these objects, including the gold database, like in the databases file, right? We have, you know, we say, yep, create the gold database, there it is. And then we basically just like, this is like our little metadata flag. We say it's managed by dbt. People understand basically then when they run dbt jobs, dbt is managing everything that's created in there, because that's just way easier. It doesn't make sense to try and make Terraform and dbt consistent with each other in terms of what exists. So who manages this? Essentially just like the data eng team manages the Terraform files. And it's just like, it's a safe way for anybody to verify the state of the architecture at a given time. So a good example of that would be if we go to the grants file, if we look at like ownership, it's quickly, like it's easy to see, especially for roles here. It's easy to see. So these are examples of some of our users. I was actually supposed to change the name of these, but these are some of my teammates at Ritual. But basically, it's very easy to say like, who's an account admin, and then like their names are listed. Anyone can kind of like easily read this file and verify it. The learning curve for Terraform is actually pretty like flat. Like it's not, once this is all set up, multiple people on our team sort of have contributed without being Terraform experts, because of basically like they can just follow the kind of like format of the file that exists. In VS Code and probably other IDEs, there's some nice sort of syntax verification, so that's resolved. And then finally, like with the CI that like fully tests their changes, like integration tests on the change with everything else in the architecture, we're just confident. We're like, great, it passed merge, and then it gets applied. So it's basically like not everyone has to be an account admin to say like, I want a new privilege or something, and I need you to go in and do it. They just look at it and say, oh, I don't have this privilege. Here's my PR. I'd like you to approve it. Can you do that?
Looks good. Thanks.
Yeah, thank you for the questions. Is there anything else, like any specific use cases? Will this work for me? Anything that people are worried about?
I've got a couple of questions, but I also know Dennis from Drizzly has a question. So Dennis, if you're free, if you want to jump in ahead of me.
Yeah, mine can be really quick. I'm Dennis. I'm a data engineer at Drizzly. I was just kind of curious of how your whole setup works with something like Snowpipes, where just like even after having created the actual objects, you kind of still have to backfill previous files or things like that, or just how that works both with CI and like how you're deploying them, and just the whole setup around that.
A teammate of mine has actually been really sort of interested in setting up a Snowflake. I wish he was on the call. I don't have as much context as him. I think the short answer is that I don't think this provider, maybe it does, has resources for Snowpipe. If so, yeah, then I don't know if he decided to use them. But basically, like with that, we set up the storage integration and the stages for the Snowpipe. But I think with regards to backfilling, that's just something that this teammate of mine managed on his own. We don't have a consistent process for that. Is that something that like you're looking to do on a regular basis, or just like obviously on the initial setup? Like what's your use case?
Oh, I was just mostly just curious because it's one of those ones where we have a few dozen Snowpipes, so it doesn't come. It's not like a daily occurrence, but it is one of those ones where it would be nice to kind of have a better process around setting those up rather than just having it be manual. So I was just curious, but we can get to Claire's more fun questions.
Yeah, I mean, we can, I'll message you later and let you know sort of how we've done that after I talk to my colleague. And yeah, I'll have to check this provider if it even includes a resource for that. I really hope that it does. That would be a glaring deficiency, unfortunately, if it didn't. So yeah, but thank you for the question.
So I have a couple of questions. So again, I'm Claire, I'm DBT Community Manager, and in my spare time, I also write SQL, YAML, and Python for fun. So we've got Taylor Murphy on the call as well from GitLab, and GitLab have developed like their own tool and open source, because everything that GitLab does is open source, which is wonderful, to manage, I guess, like the grants level of permissions in a Snowflake warehouse. So it's called permafrost. It's not so much the like creation of objects, it's more just the permissions that people or the roles have. And we've used that, and it was nice for us because it was in YAML, and I could submit a merge request with GitLab to make it do something. Teghan, I know you said you played around permafrost, and I'm interested in like, do you think that they can be used together? Do you think that it's one or the other? Do you think that like one's suited for like one use case and one for the other? Just like to try to, or do they solve the same problem, and it's just you went down the Terraform path and other people might go down the other path?
I think my opinion is that they solve the same problem, and the benefits of permafrost are that, like you said, the YAML is very intuitive. It's really straightforward, and like it's powerful and broad, and it does things like I mentioned earlier, like a deficiency in like the grants. Like it has easy syntax for like all these tables in this schema grant to whatever, right? So I think they solve the same problem. Permafrost is very easy to use. We liked it and we were originally going to use it. We decided to change because we like the idea more of kind of having like a complete overview of all the objects in our Snowflake account, including like, users and roles. So it really just depends on your use case, depends how much how much your like admins are being bugged by random teammates to like create things and do stuff. Like,
Yeah.
if you want to
Yeah,
avoid that,
lucky, we're like-
Terraform's a great option. If you
Yeah.
want to like quickly like apply a bunch of grants and make it easy to understand, permafrost is a great option.
Thank you. And the other thing that I'm always really interested in is, you've done this work and sort of learnt a lot along the way. And obviously, like, it has improved your data architecture, but there's an investment in that you have to put in terms of the work you put in. So how much effort, I guess, was start to finish of building out this like Yeti system, as you call it? And what do you think is like a good point in a data team's like maturity to think, to start thinking really hard about how do we manage our Snowflake account in a version controlled way?
Mm-hmm.
Like, is it the first thing you do, or is it sort of once you've got a data engineer on board?
Yeah, I think that like you definitely want to be a team that at least, has a data engineer. You're not just like analyst. I love analysts. It's just, I was an analyst as well, and I've been like shuffled into like this like infrastructure work because we just needed it. So I think that basically if you sense like that you're going to have like a more complex project than just like data from one source, you're going to have like a raw database, maybe multiple other databases, multiple schemas. Some of it's going to be PII that you're going to want to like control access to. And your team is like 10 plus people, then I would say this is a great sort of option for a team like that. If you're not on that, I would say like stick to dbt Cloud and permafrost, grant those permissions, and like have your analysts work mostly through dbt Cloud. Yeah.
So we've got just on 5 minutes to go. We're going to launch a really quick poll now just to get a few data points about how this office hours went, so we can keep improving. But we do have a few more minutes, so if anyone else has any questions, I think Scott had one in the chat around anonymization. I'm not sure if we got to that one or not, but yeah, we probably have time for just a couple more questions. No, just reading through your question in the chat. No, are you available to ask that one?
Sure. Yeah. Hi, I'm Noah.
Nice to meet you.
I'm a software engineer at Bowery Farms, where we are big DBT fans.
We are big Bowery
We
Farms.
are a smaller team. Yeah, we're a smaller team, and we do not have a data engineer. So kind of, I guess, riding on the coattails of that last question. But I'm definitely interested in how you kind of made the decision between what belongs in a DBT run operation and what belongs in Terraform. I think for people who are more familiar with Terraform, it makes sense to just have as much as possible in Terraform. But from, I guess, maybe an analyst perspective, and maybe other people can kind of comment on what's most useful for them. We found it very useful to have cloning operations like you have and kind of cleanup operations like you have that are part of DBT. And yeah, I guess I'm just really curious how you decided to move so much of the setup and everything out of DBT and into the separate tooling versus, I guess I can kind of imagine an entire data engineering world of DBT. Yeah.
Yeah, sure. Well, I think like the key thing here, so we were very lucky with this. Basically, the other like big benefit, I would recommend Terraform to people who are starting from scratch. And that's kind of like what we had the opportunity to do on Snowflake, is we basically were like, we are going to, build this thing starting from the beginning. We had never used this like cloud product before. We're going to like basically build up this project, this Snowflake account, and then run our analytics out of it instead of running them out of BigQuery. So I think that it's best to sort of start with Terraform, especially if you're setting up Snowflake for the first time. The reason being, after you have created all these things with manual statements in Snowflake, Terraform is like really cumbersome to import those objects and basically allow Terraform to understand that those objects already exist in the account and that Terraform now needs to be responsible for them. You have to run like manual import statements, like basically saying I've declared this resource and now Terraform needs to understand that this resource is referring to this object that I've already created differently, not through Terraform, at an earlier date in Snowflake. So it wasn't so much like a question of when moving things out of dbt. It was just like a question of using this from the beginning to sort of design and build all the objects we wanted and therefore manage them, especially our users and our roles and our grants. That's the main benefit. The other files are pretty sparse, as you can see, databases. Yeah, 2 databases, sweet. It's pretty much the users are really cool. A cool thing that people will do is they'll submit a PR creating themselves in the Snowflake account in their own grants when they join the team, right? And when people leave, we just clean up their user, stuff like that. So if you can start from scratch, Terraform's a really good option. It's more work if you have to basically assign things that already exist in your warehouse to Terraform. And then the reason that we didn't give control, or we gave control to dbt essentially over the gold database, is from our perspective, it makes sense that this transforming role owns everything in the gold database. It's the owner of the gold database. And that just dbt is incredible because it will generate the DAG of resources for you, or models for you, right? So it'll just create everything it needs to create based on the run. There's no reason to take away from that power by trying to shove Terraform in there. Terraform would not do that job as well. It's just good for mostly declaring your high level objects, your schemas, your databases, your storage integrations, your users, your grants, your roles. And then from there, you just let dbt sort of manage everything. One quick point is that we sort of solved permissions on clones and stuff through we just do a grant basically as a post hook on all our models. And that's also how we actually control exposure to NBI users, is we say if you want this model to be exposed to a BI user, you need to declare it sort of with this post hook. So that's a dbt thing as well. We don't really make Terraform manage that. It's mostly for grants, high level objects, and anyone can sort of verify the main permissions and architecture of the warehouse outside the dbt.